Hi everybody, I'm Mike Nelson. We hear a lot about ozone and whether it's good ozone or bad ozone. The ozone that we hear down at the ground level is a real problem, but the good ozone, we talk about the ozone hole and how that's also a problem. Let me do a little explainer on that. The ozone layer is found up in the stratosphere, about 25 to 30,000 feet above the surface of the Earth. Ozone, which is O3, 3 atoms of oxygen to make that molecule, is found in that area, and it actually helps to block out ultraviolet radiation that would cause sunburn and skin cancer. So that's the good ozone. The bad ozone is ground level ozone, and that's air pollution from car exhaust. And it's a chemical reaction with sunlight. It's a noxious gas, causes lung and heart irritation, and so that is the bad ozone. When we talk about an ozone alert for Denver and the Front Range, that's because of ground level ozone. You want to limit your driving, carpool if you can. Don't use gasoline-powered appliances like lawnmowers and trimmers during the heat of the day, and that can help out quite a bit. We're also seeing a lot of changes in our air quality across the West because of the wildfires we've had. And so the days of heavy smoke from wildfire, particles of smoke, and this graphic comes from our friend at Climate Central, have really been increasing over the last few decades and will continue to do so. And climate change, a warmer, drier world, is going to make that worse as we get into the decades ahead. The danger coming in from both ozone and from smoke particles is they can impact your health. They irritate your eyes, your lungs, throat irritation, heart disease effects can be worsened, premature death, asthma attacks, breathing problems. So that is a major concern. Now, as the climate gets warmer in general, these are also variables that will increase fire behavior, wind, heat, and dry conditions. That's the fire triangle as far as wildfires in the West, and we are seeing a change in the amount of hot, dry, windy days since 1973 up to recent years, about 36 days more. That's a month more of the really hot weather. In addition to that, we're seeing, as you look at a percentage of wildfire days, the days that would have significant wildfire impact, it has greatly increased across much of the West between 1973 and up until 2020, and that hasn't changed in the last 2 years. Hotter and drier weather means more big fires across the West, and although that can change from year to year, and there's other factors that enter into our fire problems, forestry management per se, or pine beetle kill, hotter and drier leads to more big fires. Now, I've had some people ask me questions. Almost entirely, the rapid increase in global carbon dioxide is being caused by fossil fuels. Some have said, is it some other process? No, it is caused by the burning of coal, oil, and natural gas. 36 billion tons of carbon dioxide are released into the atmosphere each year from the burning of those fossil fuels. And the wildfires and carbon dioxide, all of the fires, the wildfires worldwide, if you add them up, contribute less than 20% of the annual increase in carbon dioxide in our atmosphere. And since the carbon dioxide is from the burning of trees, crops, and grasses, much of it is reabsorbed into new growing plants each year. It's the digging up and lighting on fire of the fossil carbon that is causing the world to get warmer. People have asked me, how about the smoke from all these wildfires compared to the cooling effect a big volcano could have? Because volcanoes can sometimes block out the incoming sunlight. Well, we did some research on that. And in 1981, Mount Pinatubo down in the Philippines ejected a massive cloud of ash 20 miles into the atmosphere and did cause, over the next 2 years, the Earth to cool slightly. But what generally happens with that is that the smoke from wildfires stays near the surface to about 10 miles up into the atmosphere. It's a cooling that might happen for a short period of time, not certainly years, but maybe a few weeks in a local area. So the climate change connection is clear. The record-setting wildfires, the heat waves, the droughts, the shrinking Arctic ice, the increased tropical activity are all related to what we see in a warmer world. And the carbon dioxide that's going into the atmosphere will stay there for centuries. As a matter of fact, the carbon dioxide that was put into the air from the first automobiles, let's go with the Model T, that is still in the atmosphere over 100 years later, causing the Earth to warm. And those climate change hazards that we're going to see will be in the West. We'll have concerns of temperature, drought. We'll have water concerns, fire concerns. Central and eastern parts of the country will have more concerns from storms, hurricanes, and sea level rise. So all of these impacts are related to what we're going to expect with a warmer world. We have to plan for it.